Other useful function for inspection of data frame columns and variable types is the color inspect types and values. This function also ignores meta. So I'm gonna set this to false so that we see all the metadata. And if the data set is clean, it's not gonna show any summary or anything. This data set's pretty clean, so I'm gonna set clean outputs to false so we can see the type of output that this function generates. So for instance, this function will look at all the columns within the color data or any geodata frame and specify the type of that column. In this case, the drill hole ID is a set of strings, so it returns as a mixed type, and the coordinates and length are all floats. So it returns as floats. If there is any chance some of these could be cast to other data types, let's say all the lengths were set to 10, therefore it could be a possibility that the length is an integer because it's looking at all values and they're all round numbers. So it would show here integer as an option to cast. Sometimes we load data and the column is interpreted as float, but in reality that column is a string or a integer. So this will just highlight that that particular column could be an integer. Summary will show anything that could be relevant. Because this data set is pretty clean, there's nothing in the summary here other than a summary of the drill hole IDs. Of course, if it was a categorical variable with some geological labels, you would be able to see some of the labels in here. Of course, it cannot show everything. Just to illustrate how this would treat a something that would maybe require some attention. So let me change the drill hole length to -1. So if I do change the drill hole length to -1 and run this function, it will now show me that, oh, there is something in this drill hole length. There is this value that is negative. So it will highlight any negative number within the data frame. So this is also a sort of validation function that works with all the geodata frame. You will see in the following cells where I'm gonna use some customized checks for drilling data. So those checks are available for color data, survey data, and interval data. But for, say, just point data or any other geodata frame, you could use inspect types and values to get a summary of what is in that data frame. All right, I'll move to the validations. So in order to validate a color data, we have access to color.check. So this function is quite useful, and there's many ways of using this function. So if I press Shift Tab and look at the documentation, we are going to see a few things. Before I jump into the arguments, I would like to highlight how the items that are checked within this function are listed in the documentation. So the things that this function is going to check for are duplicate records, which means repeated drill hole ID and coordinates together. So if a record have the same drill hole ID and the same coordinates, that is for sure a duplicated record. It will also highlight duplicated drill hole IDs because technically you would expect the drill holes to be unique in a color database. And it will also highlight duplicate coordinates, which maybe is not an issue. Maybe you really drilled from the same color to different drill holes, but it will still highlight that data. Other things it will check is for any missing coordinate value or ID value. So those would be highlighted as problematic since coordinates are quite a requirement for caller. Other things that it's gonna check for is if any of the coordinate columns contains any non-numeric values. It will take a look at the spatial distribution of the colors and highlight any spatial outlier. So if you have a data point that's far off in the space, it will highlight that data point as possible outliers. And lastly, it will take a look at mixed data types. In this context, mixed data types means that, say, in one column of your data frame, you might have numbers and strings in the same column. This is problematic in general and requires data cleaning. So you really only want one type of data in each column of your data frame. So those would be highlighted as well. Now let's take a look at the actual argument. So for this function, the main argument here would be the report, and this specifies the report type. So if I take a look at the documentation, we see that we have 3 types of reports. So one report type is a summary. So this report is just going to produce a data frame listing all the issues that it was found in the data, with the number of occurrences of that particular issue. The second report type is the Boolean report type. So this will return a copy of your caller data with an additional or many additional columns, one for each of the items that are checked, with a true or false variable indicating the locations where that particular issue was found. And the last one is the string. The string is gonna also create a copy of your caller, but it's gonna add this result of the check column, which contains a string for each data location, and this string is just going to list for each data location all the issues that were found for that data location. The second argument, and the other one that I'm going to be mentioning, is the ignore warnings. So you will see that when we run the check function, if any issue is found, it's going to generate a warning. But if we are handling these issues within our notebook, maybe we do not want to see the warning every time we run it, because we are just doing the check in order to fix the data, and we're going to fix the data. So we decide not to show the warning if I say ignore warning set to true. So let's take a look at some of the results. Let's start with the option string, and let's keep the warning on. So if I run this function, it's not going to generate warnings because no issues were found with the data. So let's actually create an issue, a problematic data. So in this case, I'm gonna set easting at location 0 to be a non-numeric value, which is the string A. So if I run this, and I keep typing lock, so if I run this, I just set the first location. So if I do head, now my coordinate is set to A, which is not a number. So if I run my check again, it's now gonna generate a warning telling me, hey, column easting has mixed data types. And then I'll get a report saying that, well, we have no numeric coordinates, and also because we have strings and numbers, it also generates a warning related to mixed data types, which is actually the two warnings that we see in red. So let's say we know what we are doing and we just don't want to see this red color warning in here. So I can say ignore warnings equals true. So it's just going to ignore the warnings, but it's still going to generate my output. So this is the output of the string. So it generates a column with a string with a list of all the issues that were found for that data location. The next type of the report that we're going to look at is the Boolean one. So if I do Boolean and run this function again, now you will see that for each one of the issues that were found for this data set, we are creating a new column, and this column contains a Boolean array where it's true if that location has the problem, or false if that location does not have that particular problem. So as we know, we found two problems for this location, so both are set to true and everything else is set to false. And lastly, we can take a look at the summary report. And the summary report is going to generate a data frame, a table with the issues that were found as indexes, and also a column with the count of how many instances of that issue was found within the data. So my data actually does not have any issue, because if I just load it again and make sure I do not change anything, you will see that the check returns empty. And that's what you want to see, that your data is clean so you can proceed to the next steps. And with this, we conclude the loading of caller data, and we can move into survey data.